Anyone who installed the Oracle 11G client?
Yeah.
Yes. Does it work?
Many errors.
Many errors?
Yeah. So I installed it.
11G
connected
client?
from the home.
So can you connect to the Oracle server at UB from your home using 11G client?
Yeah. Using the secret.
Okay. Then what
I'll
about you?
help.
So I didn't test because I saw the 10G client are available, but when I checked it, the link was gone. So you cannot download the 10G client. So I think the Oracle does not support the 10G client. So is it the 11G or 10G?
I think it was 10G.
10G?
I found it somewhere. Yeah.
Some other place,
Yeah.
which is not supported officially, right? So what about you? So 11G?
11G.
So what is your operating system? Windows 7. So I'm going to test. I didn't test 11G with Windows 7, but you cannot. Can you install anyway?
Install halfway, nearly done, but there was some error. And
Even during the installation, it's not our problem.
Yeah.
Okay, I think that's the different problem.
Yeah. Did you?
Yeah, at least it should be installed.
Yeah. And when I run the application, the terminal, I already connected SSH. I already logged into my UB account. And when I want to type in ZDU, the
SQL
account, it will not give me the window to let me type in the password. And
I think that's the difference that I cannot have. Why don't you try again? But my question is whether Oracle 11G client is comparable with the 10G server. Our server is a 10G previous, so usually they support
I use 11G.
11G client.
It's okay. The difference only is not to use the username at maybe use it only.
Okay. So you can connect from here. Okay. That probably they support, but last semester several students had problem to connect the 10G, so that's the reason I tried to upgrade our server, but the IT service delayed to upgrade when they upgrade the Windows next year. So that is the pre-project assignment. If you cannot find the 10G client, you can use the 11G, but for regular class, it doesn't matter. So you can do your homework at the lab, or even right now if you didn't finish. It's just simple. Test your username and password and run the script that I provide. You don't have to worry about, even though you understand what's going on inside the script. Okay? That's the only one. And what else? Page 1, the most students submitted. And please, okay, pretty much okay. Let me still learning. Okay. Another thing I'd like to mention is here running. A quiz. So quiz main purpose of quiz are not the grading. Okay, it's for your practice. So first thing you should not do on your quiz is do not copy others. Just try to solve the problem by yourself And if you just copy others, it's just a waste of your time, even GA and my time for grading. Okay? Usually I and GA here are generous to accept your late submission as long as you can submit within a week. Okay? Before I post the key or solution on the press website. After I post the key or solution on the press website, it doesn't make sense. So please try to solve the problem by yourself. It's for your practice. Okay? Definitely the quiz will be part of your midterm exam. It's a slightly changed format will be almost the same. So quiz will be main part of your exam. Let me press it here. So we have 1, 2, 3, 5, 6, 7. We have 13, so 6 students missing. Before we start, I briefly review our previous class. So this is the information that we are going to manage. Okay? Then this is for human being, as I keep saying. So our goal is there any way to manage such a bunch of huge amount of information efficiently and effectively using computer. So our target is to use a computer. It can be a personal computer, it can be server, but doesn't matter what types of server you use. Anyway, we'd like to put this information to the computer. So if computer is same as human being, we can just ask why don't you manage the information just like that. As I asked my GA, why don't you manage the student grading or student submission or class activity? Then he can do by himself. Unlike the human being, computer cannot do such a thing. Instead, we need to provide something different way. That is data structure. It's not only for the database problem, but all computer science, computer engineering have the same problem. When you develop a new device for computer, that device definitely need to process such information, right? At that time, you should make the standard or something structured, how to manage, how to process. Okay, most of the contents in standard, like for example, I developed a new interface for FireWire, which is ABC. It's better than FireWire. So you need to define how to send the data and what will be the bandwidth, how we can use. When you send the data, you should follow this format. You start with 0 and end with 0, and the size of the basic unit of transferring will be 1 megabyte, for example. That is the rule, that is the standard, that is the data structure. So, just like that, when we manage the information, we try to organize such information to the database. First step was, why don't we change such a cloud information as an ER style, entity relationship model. It's much more organized. Right? So in this case, the Lee is teaching database, the John is taking a course taught by Lee, bunch of information. But if we use such a ER entity relationship diagram, teach student, much easier to understand. Also much easier to be used for computer. But still, that's not enough. That is the ER model or conceptual model, high level model, and so on. we need to get close more to computer. To do that, this is one type of a model. We need another type of a model, that is database model. Database is a collection of data. It's a computer science terminology. Data modeling is not only for computer science. It's not only computer. It can be used for engineering. It can be used for finance. It can be used for even, why don't you go to the business school? They have a lot of course relating to data analytics, business data flow, and something like that. Even CRM, customer relationship management, is based on data. What data warehousing they are dealing with such a topic. It's a data. It's not like the data structure, but we need something more organized model. That is the database model. Database model define how to put such a data into computer trace. So there are many such a database model, network model, object-oriented model, or the hierarchical model, and also relational database model that we are going to learn in this class, today's class. Okay? So then, after you finish this one, you probably understand how computer manage such a data. How? That how means the data structure. You should understand how the data structure consists of. So we will learn such a thing. I don't know where the demo. Does it start the recording? It's already start? Oh, yes. I didn't know that. Okay. So today we are going to discuss about the relational model. Long time ago, can you remember what happened at the time? Professor Lee was born. Okay. Another thing is the Neil Armstrong landed on the moon first time. And another important thing in computer science was actually there are two main communities, ACM and IEEE. Actually, IEEE is IEEE is a kind of the community, research community. Then one of the popular paper, most famous paper published in ACM, the research community, was the database related one. So 1969, there was one researcher whose name is Dr. E.F. Cole. So he was in the IBM Almaden Research Center. So IBM, there are many well-known research centers worldwide, not only for the United States, in Canada, and China, and India. So Almaden is very well-known for data-related things. So in that research group, they had one problem. At that time, the computer is getting popular, so they need something new data structure to manage a very large database, because at that time still the computing power is very small. Think about the hard disk drive. Even they may not have the more than 2 megabyte, 1 megabyte hard disk drive, and memory is very small. So but the data size is getting bigger, like the 2 megabyte, 3 megabyte. But anyway, comparing to the computing power, data size is huge. So they need something new data structure to manage such a very large data. So until that time, they used something hierarchical database model. Hierarchical database model is simple. So when you think about the banking system, we have the bank. Under the bank, there are the sector, like the retail center, customer managed center, and something other center. In retail center, it has the region 1, region 2, region 3, or east coast, or west coast, Middle East, something like that. And northeast, there are branches. Under the branch, it has manager and customer and loan and so on. Customer, it has the account, and this one may have the same structure. So when you access the data in a bank, first you need to start from bank, and next level, and next level, and next level, next level, then finally you can get the data. The benefit of this one is, what can be the advantage? Easy. Also, very fast. It's just to get next, which is what the function name is get next. You can get next, next level. Okay, it's not very complicated. Also, very fast and secure. It's in terms of security, it's very reliable. The main problem is
it's not searchable. It's difficult to search.
Search overall. So I need something average balance of all accounts in the bank. Then to do that, you need to access this one. Then you need to access this one. You need to access this one. So it takes long time to collect all the information. Also, sometimes you may open the account over here, account over here. Also, you may have the loan account over here, right? At that time, I need just my statement. To do that, it takes longer time to access. So it's not very practical for nowadays online transaction process. So they'd like the research group would like to address such a problem that he got the idea, as I mentioned the last class, he got the idea. Why don't we use some mathematical form that is a set theory? What is a set? It's a group of elements. Everybody knows. Then, like the 1, 2, 3, it's a natural number n. Right? It's a group of elements. Think about the entity over here. Like we have the student. Entity, like the Lee, CSC, and address is 100 University Avenue, and the GPA is 1.0. And the John, and EE, the 101 University Avenue 2.0, and so on. We have such an entity. What data, whatever. Then this is one entity, one entity, one entity. Why don't we consider this as the element? Element, element, element. Then the student can be element 1, element 2, element n, group of element, group of data. Or sometimes this is called data, this is row, this is entity, group of something. That is a set. So student entity type is the same as a set. Then what can be the benefit if we regard group of data as a set? What can be the benefit? Why did Dr. E.F. Code get such an idea? That's a key point.
Apply operations.
Operation, that's a good point. So set theory as you know, the mathematics is the most perfect, the logic and algorithm. So if you have a new idea, whatever, if you can prove your idea with the mathematics, that's perfect. You don't have to test, you don't have to implement, you don't have to simulate. Okay? If you prove a times 0 is 0, if you can prove in mathematics equation, do you need to test everything? You cannot do that. 1 times 0, yes, true. 2 times 0, 0. So you did 1,000 times. Are they perfect? Not yet. You need to, what about 1,001, 1,002, 1 million, 10 million, tons of millions of millions? Infinite number. Definitely you cannot test all the case. Who knows? There might be something, number times 0 is not 0. Instead, if you can prove that this one with the mathematics, that's it. Similarly, in computer it's the same. You have the new idea. For example, any PhD student, so you probably propose your own research topic, right? When you graduate.
Yeah.
So what is the best way to prove your idea? It's a mathematics. At that time you don't have to code, you don't have to test, you don't have to implement. If you can prove your idea with the mathematics. But it's not easy sometimes.
Yeah.
So that's the reason in computer, sometimes error, like even the commercial product has bunch of bug, error, and the parameter. So at the time you need to test, you need to implement, you need to evaluate, you need to simulate. Okay? It's a secondary. So, but here, mathematics, using the mathematics term, set theory has this amount of big text. It has bunch of operation, okay, like the union, intersection, minus, and what else? Bunch of, so Cartesian product, and so on. That's already proved, somebody already did. So we can adapt, we can use such an existing operation using set theory. Then we can easily manipulate, process such a data, very large data. That's the key point. That's the reason he got the idea. Why don't we use the set theory for this one? So he doesn't use the same name as the set. Instead, he changed the name as relation. So relation is the same as set. Okay? So when you are hearing, when you read, when you see such a relation, that means it's a set. So that is the reason, think about something, if you already created a table using DBMS, any DBMS, you probably create table student and blah 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 column. So student table is a group of data, student data. So group of my student, group of something. So that's the main idea of the relational model, relation. It's the same as a set. So what is a relation? Relation is a group of element, not element is the terminology in set theory. So it's a computer science. So relation is a group of data or group of rows, group of entity. That is the definition. Okay? So let's start the chapter 3. So this is the paper title, one of the most famous paper. Still, I think that this one is the most cited or reference paper in computer science. So a relational model for large shared data banks. Banks means something database or warehouse. So it's published in 1970. Then in this paper he tried to adapt the set theory to manage the data manage the data means to make the data structure, database model. So he defined the relation as a set of rows or set of columns. What does that mean, set of columns? So let's take a look at this example. So this is the data for student, right? This is another data. We have 5 data, 5 rows, 5 entities. So group of data as the set, not set, relation, student relation, right? However, why don't we see it? Can we see this student relation as the attribute? What does that mean? Because each data has name, social security number, home phone number, address, office number, age, and GPA. What about the next, Ashley? Ashley has the name, social security, and so on. What about the Davidson? Davidson has also the same attribute. So each and every data has the same attribute that are name, social security number, and so on. So we can see that this student relation as the set of columns or set of attributes. It's not only row by row. Instead, we can see the data as attribute, 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 attribute. So we can say a relation, a table, a relation is set of attribute, set of column. Actually, that is a very important point. So, how many DBMS do you know? Relational database system. Oracle, Informix, DB2, IBS, SQL Server, anything else? So, you provide most of the commercial relational DBMS use this definition, a set of data or rows or entities. This way, they are very good, very nice to access the data by rows. Okay. However, it takes some time because they manage the data as a row, as a row, as a row, or student by student by student. But sometimes you want to access the average GPA of 10 millions of the data. Then you need to access this one. You need to access this one, this one. So it takes longer time. So current DBMS system is very good for access by rows, access by data, but not good for access by. But nowadays, this is very important. For example, think about the Facebook. Facebook, how many users, how many messages? If you manage the Facebook message like this way, message by message by message, so sometimes you want to search any message that includes something GPA. So not 10,000 message, it's a tera size, more than tera size, the message in the world, in Facebook. When you access such a huge amount of data, not very large data by column, no, commercial DBMS cannot provide such a transaction. So nowadays, the column by attribute is very important. It's another types of DBMS, data model, which we are not going to deal with details, but end of semester, I'd like to introduce very briefly about such a new generation, new trend of the database model. Okay, sometimes it's called the NoSQL.
So SQL will be not used on that.
SQL is the language. Language is the interface between you and me. But NoSQL does not mean we are going to throw away the SQL, but it's try to address the limitation of relational model. Okay? It's not the exactly opposite of the relational model, but try to address problem of this one. Because actually relational model is you are going to learn details. But you will realize it's very simple. It's easy to use. But because of that, it's very limited, not flexible. So we'd like to address essentially later. First, we should know how the relational model is organized. So this is, we can see the relation two ways. One is row by row. Another way is column by column. So another reason why data row by row access is popular is how many columns do you have in your database? Roughly 10, 20 attributes. How many attributes? 30? Less than 30, right? How many data? 1,000, million. So comparing